Welcome back. So, in the last topic we were discussing about the types of beams. Already we discussed the cantilever beam and the simply supported beam also we discussed. That is, the simply supported beam is nothing but having a both ends support, whether it might be any type of roller support or any hinge support. So, hinge support is nothing but where we can able to see the support that has been fixed to the doors or in a windows, where you can able to see the hinges has been attached to the doors or windows, where it has been having the support, similar type of support. So the next one we can able to see is about an overhanging support. See there in this overhanging support, the between the in between the beams only we are going to give the support. So at the both ends there will be no support, but in between that we will be having a supports, where you can able to see in this at the starting or ending of the beam will be not having any supports like in a simply supported or a cantilever beam, but in between the starting and ending we are going to give the supports. This type of beams are called as an overhanging beams. So and we can able to see the next one is about an continuous support beam. So the continuous beams is nothing but it will be having a support throughout the beams, where you can able to see we have four supports here. Like this will be depends upon the beam or depends upon the application, where this type of continuous beams is required based on the requirement from the customer or requirement from the engineer. They're going to use this type of beams, continuous beams. See, and the next one is about the fixed beam is nothing but both ends will be having a fixed. So only both ends it will be fixed, no other like roller or a hinge support. So in the both ends it will be completely fixed. This type of is we called as a fixed beam. And this is a combination of all the beams, whether it is the cantilever one side if you fixed, and if I leave a free cantilever, or if we given a support on the other end, it will become a simply supported or an overhanging. See, this all these types of beams is depends upon the requirement, where mainly it is going to be used, or what is the different purpose of using these types of beams. So this will be decided by an engineer, where mainly the distribution of load, whether what type of beam is suitable for at this particular condition or at this particular application. So next about the first we have seen about the different types of beams. So next we're going to see about the what are the different types of loads will be acted on, particularly on these types of beams. So mainly we can able to see this first one, where we can able to see it's in a point load. So this point load is nothing but only at one certain point, or one at one particular point only the load will be acting. Other entire of the beam, only one particular point will be acting. The load will be acting only at this particular point. So remaining the beam there will be no load will be acting on this beam. So this type of load we call it as a point load. Again, see, this load is not depends upon the where we have been used, or what type of load, only exactly that particular point of a load where it has been applicable to this beam. See, again this type of load is only particular load or particular only one point, or particularly at this point only the load is acting on this throughout beam. So next one is about uniformly distributed load, or we call it as equally distributed load, where you can able to see this is a beam having an one end it is in a fixed and other end we have in a roller support. So now the load is entirely distributed, or equally the load will be the equally the load is distributed on these beams. See, this mainly this type of uniformly distributed load is on the walls, or the both the beams are been located on the walls, where this entire load of the roof which is there, that load will be the roof load which is there, that load will be acted, or entirely the load is acted, or load is equally distributed on the this beam. This type of beam mainly we call it as a uniformly distributed load. So not only this type of load is uniformly distributed only the beams, even on the components also, or even in the machineries also this type of load will be utilized. And the next one is about the uniformly varying load, or we call it as a triangularly distributed load. So you can able to see at the point of the starting of the beginning, even you can see one end it is fixed and one other end of this beam will be having a roller support, what they have considered. So you can able to see it is gradually decreasing, or if you consider from this end, see the load is gradually increasing from one point to other point. You can able to see at this point the load is increased, and the next one is again it is increased. So similarly it is uniformly varying load. Varying means from one point to other point, or from one part to the other point the load is continuously varying from starting till the end. So again even this also, so now we can able to see the uniformly distributed and uniformly varying load is also uniformly distributed is the load entirely completely distributed on the beam. But when if you take an uniformly varying load, automatically what happens, this uniformly varying load is nothing but this load will be uniformly varying from one point to other. See, these are all depends upon where the application. See, normally the uniformly distributed load or a point load is only if you take as an for an porticos, where you can able to see at only one particular point it has been, the load will be used. Or the uniformly distributed means what the column which has been placed on the walls that will take. So these are all depends upon the different applications where the requirement of the customer. Based on that only we're going to design the construction of house. So based on the design only we're going to fix the which type of beam is suitable at this particular requirement or at this particular condition. Based on the requirement only we're going to select the different types of beams. So next one is here one what we have seen, the uniformly varying. That in that uniformly varying another type is what we call as a trapezoidal distributor. So that is also uniformly varying load. You can see the load is varying from starting, you can see from this point to this point, from this point to second to third, third to fourth, fourth, like similarly like this. So the uniformly the load is completely varying from one point to other, from other point. So all the beams has been utilized at one or other point of construction, or all the types of loads has been used at one or other condition, but all the depends upon the requirement or the application, where mainly exactly where particularly this type of beam is only required at that particular condition only this type of beams will be utilized. And the next one is about a moment. So where will be this moment only, the movement or the rotation or been takes place, means only the movement takes place, not only the shear force. Along with this shear force the movement also takes place. Movement is nothing but whatever the shear force is acting, based on that the movement also acts along with the shear force. So these are all the different types of loads that has been used in the on the beams. So all the loads cannot be selected without blindly. So the requirement are based on the application of the where we are going to exactly use. Based on that only we are going to select the this type of different types of beams with the different conditions.